On April 12th, 1952, a photographic plate exposed at the Palomar Observatory captured something impossible. Among the thousands of white pinpricks scattered across the emulsion, one star burned brighter than its neighbors, a reliable beacon in the constellation Lupus that had been there for as long as humans had looked up. Then, without warning, without any detectable explosion or dying gasp, it simply ceased to exist. When astronomers compared plates from different years, searching through decades of archival images, they found something that shouldn't be possible in a universe governed by the laws of physics we understand. The star was there in 1950, burning steadily. It was there in 1951, unchanged. But by 1953, there was only darkness where it had been, as if someone had reached up and plucked it from the sky like a dying light bulb. No supernova remnant, no expanding shell of gas, no afterglow, just empty space where a sun had once lived. And here's what kept astronomers awake at night, what made them check and recheck their calculations until their eyes burned from staring at photographic plates under dim red lights. When they looked at more recent surveys of that same patch of sky, something was there again. A faint glimmer, a whisper of light. But it wasn't in quite the same place. The story begins not in 1952, but in 2016, when a team of astronomers launched one of the most ambitious celestial archaeology projects ever conceived. They called it VASCO, the vanishing and appearing sources during a century of observations. And their goal was deceptively simple. Compare old photographic plates from the mid-20th century with modern digital sky surveys to find stars that had vanished. The universe, they knew, was supposed to be relatively stable on human timescales. Stars don't just disappear. They live for millions or billions of years, burning through their nuclear fuel in a slow, predictable dance of fusion and gravity. When they die, they go out spectacularly, in supernovae that briefly outshine entire galaxies, leaving behind neutron stars or black holes surrounded by glowing debris that remains visible for thousands of years. A star simply winking out of existence without a trace violated everything we knew about stellar evolution. It was impossible. And yet, as the VASCO team began their systematic comparison of old and new sky surveys, they found that the impossible was happening more often than anyone had imagined. The observatory that night was cold, perched on a mountain peak far from city lights, where the air was thin and the stars seemed close enough to touch. Inside, a young graduate student named Beatriz Villarroel sat before a computer screen, her eyes moving methodically across images that showed the same patch of sky photographed 70 years apart. This was tedious work, the kind that required absolute concentration and the patience to examine thousands of stars, one by one, looking for discrepancies. Most nights yielded nothing. A slight difference in brightness here, an artifact from the photographic process there. But nothing truly anomalous. Then she saw it. In the left panel, the 1952 image, a star glowed with unmistakable clarity. In the right panel, the modern survey, there was nothing but the dark velvet of space. She leaned closer, her breath fogging the screen slightly, and felt the hairs on her arms stand up. This wasn't a photographic flaw. The star was surrounded by other stars that matched perfectly between the two images, proving the alignment was correct. This star had simply ceased to exist. Within weeks, the VASCO team had identified not just one, but hundreds of candidates, stars that had burned in the night sky when Harry Truman was president, when the first hydrogen bomb was being tested, when humans had not yet ventured into space, were now gone, vanished. The scientific community's first instinct was skepticism, a healthy reaction in a field where extraordinary claims require extraordinary evidence. Perhaps these were photographic artifacts, defects in the old glass plates where emulsion had flaked away or been damaged. Perhaps they were asteroids passing through the frame, captured in a single exposure and mistaken for stars. Perhaps they were variable stars in a dim phase, stars whose brightness fluctuates over time, creating the illusion of disappearance. The Vasco team anticipated every objection and systematically addressed them. They cross-referenced multiple photographic plates from different observatories, different telescopes, different dates. They checked for asteroids and satellites. They analyzed the spectral characteristics of the vanished stars when data was available. And with each test, more candidates fell away, explained by mundane causes. But a stubborn remainder persisted. These were genuine stars, burning at consistent brightness across multiple observations, that had simply vanished without explanation. The deeper they dug into the data, the stranger it became. Some of the vanished stars showed peculiar characteristics before they disappeared. One star in the constellation, Cygnus, had been observed to slowly fade over a period of 3 years, dimming gradually as if something was passing in front of it, blocking more and more of its light until it winked out completely. When modern telescopes were aimed at its last known position, they found absolutely nothing. Not even a faint infrared glow that might suggest a dusty disk or a cloud of gas. Another star had pulsed irregularly in the months before its disappearance, brightening and dimming in a chaotic pattern that didn't match any known type of variable star. Then it too went dark, leaving behind only questions and the faint ghost of itself on old photographic plates. The Vasco team published their initial findings in 2019, presenting a catalog of 100 confirmed vanishing candidates that could not be easily explained. The paper sent ripples through the astronomical community, not because it claimed to have solved a mystery, but because it revealed that the mystery existed at all. The physics of how stars die is one of the most well-understood areas of astrophysics, refined over a century of observation and theoretical work. When a massive star exhausts its nuclear fuel, the outward pressure from fusion that has held it up against gravity for millions of years suddenly stops. The core collapses in fractions of a second, compressing matter to unimaginable densities until the collapse halts violently, sending a shockwave back out through the star's outer layers. This shockwave tears the star apart in a supernova explosion so bright it can be seen across the entire observable universe. The explosion leaves behind either a neutron star, a sphere of nuclear matter barely 10 miles across but containing more mass than the Sun, or a black hole, a region of space-time so warped that nothing, not even light, can escape. Both outcomes are visible. Neutron stars spin and pulse, sending out beams of radiation like cosmic lighthouses. Black holes, despite their name, are surrounded by brilliant accretion disks of superheated matter spiraling inward. And supernovae themselves blaze for weeks or months, impossible to miss. Yet none of the vanished stars in the Vasco catalog showed any evidence of having gone supernova. There were no remnants, no expanding shells of gas, no neutron stars, no black holes with accretion disks. Just emptiness. This is where the theories began, each more unsettling than the last. The first and most conservative explanation was the failed supernova hypothesis. In rare cases, theoretical models suggested a massive star's core collapse might not produce an outward explosion at all. Instead, the core would collapse directly into a black hole, and the black hole would immediately begin swallowing the star's outer layers from the inside. The star would implode rather than explode, its light cut off as matter fell inward past the event horizon. This process, if it happened quickly enough, might leave no visible remnant, no explosion, just a star that was there one moment and gone the next. Astronomers had long speculated about failed supernovae, but they had never definitively observed one. The math worked, the physics was sound. But it had remained purely theoretical until astronomers began focusing their attention on one particular star, N6946bh1, a red supergiant in a nearby galaxy that had begun to brighten in 2009, then simply vanished. Follow-up observations showed no supernova, no remnant, nothing. The consensus was that they had witnessed a failed supernova, a star collapsing directly into a black hole. But this explanation could only account for some of the vanishing stars. Others were too small, too low in mass to undergo this kind of dramatic collapse. Something else was happening. The second theory was more exotic and more troubling. What if some of these stars weren't vanishing at all, but being obscured? Not by dust or gas, which would still show up in infrared observations, but by something solid, something massive, something constructed. In 1960, physicist Freeman Dyson had proposed a thought experiment. An advanced civilization with enormous energy needs might eventually disassemble the planets in their solar system and use the material to build a megastructure around their star, capturing all of its light for energy. Such a structure, a Dyson sphere, would make the star appear to vanish in visible light while glowing brightly in infrared from the waste heat. When astronomers looked at some of the vanished stars in infrared, they found nothing. But Dyson spheres exist on a spectrum, and a partially completed sphere or a swarm of collectors might create exactly the dimming pattern observed before some stars disappeared. The idea seemed like science fiction, the kind of speculation best left to late-night discussions over coffee. But the universe is vast and old, and the number of potentially habitable planets numbers in the billions just in our galaxy alone. If technological civilizations arise even rarely, some should be millions of years ahead of us in development. And what would they look like? How would they engineer their environments? The unsettling truth was that astronomers didn't know what to expect, and couldn't rule out the possibility that some vanishing stars might be artificial in origin. But the real mystery, the one that transformed curious academic interest into something approaching dread, emerged when the Vasco team began their second phase of research. They had been searching for vanishing stars, objects that were present in old surveys but absent in modern ones. Now they decided to flip the search, looking for stars that appeared in modern surveys but were absent from old photographic plates. These would be appearing stars, new objects in the sky where nothing had been before. They expected to find mostly known phenomena, novae, stellar explosions that temporarily brighten a star system, distant supernovae in other galaxies, asteroids and satellites accidentally included in their search. What they found instead were objects that matched none of these categories. Stars that simply appeared in the sky where old surveys showed empty space, burning steadily as if they had always been there, even though the historical record proved they hadn't. And in a handful of cases that made veteran astronomers set down their coffee and stare at the data in disbelief. Stars that had vanished from one position appeared to have reappeared in another, slightly displaced from their original location. The displacement was small, only a few arc-seconds on the sky, the kind of distance that might seem insignificant to anyone unfamiliar with astronomy. But stars don't move like that. They have proper motion, a slow drift across the sky caused by their movement through space relative to the sun. But this motion is predictable, measurable, and consistent. A star doesn't vanish from one spot and reappear a few arc seconds away decades later. That would require impossible accelerations, speeds that would tear the star apart, energies that dwarf anything we can produce or explain. Yet the data was clear. Multiple independent surveys confirmed the same pattern. A star visible in a 1950s photographic plate at one position, absent from all surveys for decades. Then present in a 2010s digital survey at a slightly different position. The odds of this being a coincidence of two different stars randomly appearing and disappearing in nearly the same spot were astronomically small. Something impossible was happening, and the only question was which impossibility to believe. One night in 2021, as the Vasco team gathered in a video conference to discuss their latest findings, the conversation took a darker turn. They had been treating this as a scientific puzzle, an interesting anomaly that would eventually yield to careful analysis and patient observation. But as they reviewed the catalog of vanishing and appearing sources, patterns began to emerge that none of them wanted to say aloud. The vanishing stars weren't distributed randomly across the sky. They clustered in certain regions, particularly toward the galactic plane where stars are densest, but not in the way that random chance would produce. Some clusters formed geometrical patterns, rough lines, and triangles that could be coincidence or could be something else. More disturbing was the temporal pattern. The rate of vanishing seemed to be increasing. In the 1950s, they found approximately 2 vanishing candidates per year. In the 1960s and 1970s, the rate climbed to 5 per year. By the 1990s, accounting for the increasing sensitivity and coverage of sky surveys, the rate appeared to have doubled again. Either detection methods were improving to the point where they were catching more events or something was happening more frequently than it had before. The hypothesis that no one wanted to voice, but everyone was thinking about, was this: what if the vanishings and reappearances weren't natural phenomena at all, but evidence of technology beyond our comprehension? Not just Dyson spheres, but something stranger. Wormholes, perhaps. Artificial tunnels through space-time that could transport matter from one location to another, making a star disappear from one position and reappear in another. Or massive gravitational lensing devices, capable of bending light so severely that a star's image could be displaced or rendered invisible. Or stellar engines, hypothetical megastructures that could move entire stars, harvesting their energy while relocating them across the galaxy. Each possibility sounded more like science fiction than science, and yet the data demanded explanation. The universe was showing them something unprecedented, and the only choice was between impossible natural phenomena and impossible artificial ones. Neither option was comforting. Natural phenomena that could make stars vanish suggested physics far stranger than anything in our textbooks. Holes in our understanding of reality itself. Artificial explanations suggested we were not alone in the universe, and that whatever shared the cosmos with us operated on scales of engineering that reduced our greatest achievements to child's play. The astronomical community responded with a mixture of intense interest and profound skepticism. Critics pointed out that the Vasco data, while intriguing, was based on comparing photographic plates of varying quality with modern digital surveys. Photographic astronomy was an art as much as a science, dependent on exposure times, atmospheric conditions, the quality of the emulsion, the skill of the observer. Perhaps the vanishing stars were simply never there in the first place, artifacts of overexposure or chemical imperfections in the plates. The Vasco team countered by showing that many of their candidates appeared on multiple plates from different observatories, taken at different times, ruling out single exposure artifacts. They showed that the vanished stars had consistent brightness and color, characteristics that matched real stellar objects rather than defects. And they invited critics to examine the data themselves, making their entire catalog publicly available. Some critics were convinced. Others remained doubtful. And a small group of astronomers, those who had spent decades studying stellar evolution and knew how thoroughly we understood these processes, simply had no explanation to offer. The vanishing stars shouldn't exist, and yet they did. The story took its strangest turn in early 2022, when an amateur astronomer in Australia, poring through the VASCO catalog out of pure curiosity, noticed something the professional researchers had missed. 3 of the vanishing stars in the catalog, scattered across different regions of the sky with no apparent connection, had been observed by the same telescope on the same night in 1954, during a routine survey of the southern sky. On that particular night, the telescope had photographed each star's region, and each star had appeared normal, unremarkable. Follow-up observations from the same telescope 2 years later showed all 3 stars had vanished. The amateur astronomer checked weather records from the observatory for that night in 1954 and found they were perfect, clear skies with excellent seeing conditions. He checked for technical problems with the telescope, any issues that might have been noted in the observatory logs, and found nothing. 3 stars, observed on the same night, all vanished within the same 2-year window. The probability of this being coincidence was vanishingly small. Something had happened to those stars, something coordinated, something that affected multiple stellar systems separated by hundreds of light-years of space. The implications cascaded through the minds of everyone who studied the data. If the vanishings were natural phenomena, this suggested some kind of catastrophic event that could propagate through space, affecting multiple star systems simultaneously. But what natural phenomenon could do that? A shock wave from a massive explosion would take thousands of years to cross the distances involved and would be easily detectable. Gravitational waves from colliding black holes or neutron stars could theoretically affect wide regions of space, but would never make stars simply disappear. There was no natural mechanism that fit the data, which left only unnatural ones. Coordinated action by intelligence, perhaps, megastructures being built around multiple stars simultaneously by a civilization working at galactic scales. Or something even stranger, evidence of phenomena we had no framework to understand, signatures of physics beyond our current theories. The universe might be telling us that our understanding of reality was incomplete, that we were like ancient humans watching lightning and having no concept of electricity, no way to comprehend what they were seeing. As months turned into years and the VASCO project continued its systematic survey, new vanishing candidates kept appearing in the data. Each one was carefully vetted, cross-referenced against multiple surveys, checked for every possible mundane explanation. The catalog grew to 200 confirmed candidates, then 300. And with each new addition, the patterns became harder to ignore. Most of the vanishing stars were red giants or supergiants, massive old stars near the end of their lives. This made sense if the mechanism was failed supernovae. But it didn't explain the displacement cases, the stars that reappeared in different positions. A smaller number were main sequence stars, ordinary suns like our own, that should be stable for billions of years, yet had simply ceased to exist. These were the most troubling cases, because they had no conventional explanation at all. A main sequence star doesn't collapse into a black hole. It doesn't undergo a failed supernova. It just burns steadily for eons until it eventually swells into a red giant billions of years in the future. Yet several of these stable stars had vanished from the sky, leaving only the faint evidence of their existence in old photographic plates. The media eventually picked up the story, though not with the sensationalism one might expect. The headlines were cautious, uncertain how to present a mystery that had no clear resolution. "Astronomers find hundreds of vanishing stars," ran one article, focusing on the failed supernova hypothesis. "The mystery of the disappearing suns," read another, speculating more freely about Dyson spheres and alien megastructures. But most people scrolled past these stories, barely registering their significance. The universe was full of strange phenomena, and one more mystery seemed like just another curiosity for scientists to puzzle over. Few grasped the profound implications, the way this discovery challenged fundamental assumptions about the stability and predictability of the cosmos. The stars were supposed to be eternal, or at least long-lived enough that their changes occurred over timescales humans couldn't perceive. The idea that they could simply vanish, that the night sky we looked up at might be missing pieces that had been there when our grandparents were children, was deeply unsettling in ways that were hard to articulate. Among the most disturbing cases in the Vasco catalog was a star designated only by its catalog number, a sequence of letters and digits that gave no hint of the mystery it represented. This star, a yellow giant roughly twice the mass of the Sun, had been photographed extensively in the 1960s by multiple observatories as part of various surveys. It showed no unusual characteristics, just a normal aging star burning through its helium fuel, destined to eventually shed its outer layers as a planetary nebula in a few million years. Then, in 1972, it dimmed. Not suddenly, but over the course of several weeks, its brightness dropping by about 20%. Astronomers at the time noted the dimming in their logs, but didn't find it particularly remarkable. Variable stars dim and brighten for various reasons. They assumed this was a passing dust cloud, or perhaps a stellar companion eclipsing it. By 1973, the star had dimmed further, now at only 50% of its original brightness. This was more unusual, and one astronomer made a note to conduct follow-up observations. But funding was tight, telescope time was precious, and there were always too many objects to observe. The follow-up never happened. When modern surveys finally imaged that region of sky again in 2005, the star was completely gone. No remnant, no nebula, no dim companion, just empty space where a yellow giant had slowly faded away. The pattern of dimming before vanishing appeared in several other cases, enough to suggest it might be significant. It reminded astronomers of the famous case of Tabby's star, officially designated KIC 8462852, a star that became briefly famous in 2015 for its bizarre dimming pattern. Tabby's star would randomly drop in brightness by up to 22%, far more than any known planetary transit or stellar behavior could explain. The dimming episodes were irregular, unpredictable, and utterly anomalous. Speculation ran wild, with serious scientists proposing everything from cometary swarms to alien megastructures. Eventually, the consensus settled on a massive debris field, possibly from a destroyed planet or comet, passing in front of the star. But Tabby's star hadn't vanished. It was still there, still dimming and brightening in its strange way, still defying easy explanation. The vanishing stars in the Vasco catalog had gone further. Their dimming hadn't stopped at 20% or even 50%. It had continued all the way to zero, to complete darkness, to absence. What haunted the researchers most was the question of scale. If even a small fraction of the vanishing stars were being obscured by megastructures, by Dyson spheres or stellar engines or technology we couldn't imagine, then the galaxy was far more populated than anyone had suspected. The Fermi paradox. The famous question of where all the aliens were, if the universe was so vast and old, might have a simple answer. They were here, all around us, building and engineering and reshaping their stellar neighborhoods in ways we were only just beginning to detect. The night sky we looked up at might be partially artificial. Some natural stars and some hidden behind structures built by civilizations millions of years old. We might be living in a decorated universe, a cosmos where intelligence had already spread and modified things on scales we couldn't comprehend. And we were only now developing the tools to notice. The alternative, that the vanishings were natural phenomena we didn't understand, was somehow even more troubling. It suggested that the universe operated by rules we hadn't discovered, that our physics was incomplete in fundamental ways, that stars could cease to exist through mechanisms we couldn't predict or prevent. In 2023, a breakthrough came from an unexpected direction. A team of theoretical physicists at Cambridge, studying the properties of exotic matter and negative energy, published a paper suggesting that under very specific conditions, a sufficiently advanced civilization could create what they called a causality shield, a bubble of warped space-time that would render anything inside it invisible and unreachable from the outside. The mathematics were complex, requiring forms of matter that might not exist in nature, but could theoretically be manufactured. Inside the shield, time would flow differently, potentially much faster than in the external universe. A civilization that erected such a shield could conduct experiments, build structures, or simply exist in isolation, completely invisible to outside observers. The star at the center of the shield would vanish from our telescopes, its light trapped inside the warped space-time bubble. And if the shield were imperfect or temporary, if it flickered or moved, the star might briefly reappear, displaced from its original position by the space-time distortion. The paper was dense, filled with equations that only specialists could follow. But its implications were clear. The vanishing stars might be evidence of the most advanced technology humans had yet conceived. Artificial space-time bubbles built around stellar systems for purposes we could only guess at. The causality shield hypothesis divided the astronomical community sharply. Some dismissed it as wild speculation, untestable and unfalsifiable, the kind of exotic theory that explained everything and therefore explained nothing. Others found it compelling precisely because it made testable predictions. If the vanishing stars were surrounded by causality shields, then their disappearances should be correlated with certain gravitational wave signatures, subtle ripples in space-time that our increasingly sensitive detectors might be able to pick up. Teams began analyzing gravitational wave data from the LIGO and Virgo observatories, searching for signals coincident with the vanishing star events. The results were tantalizing, but inconclusive. Several vanishing events did correlate with weak gravitational wave signals, but the signals were at the edge of detectability, possibly just noise, possibly something real. More sensitive detectors would be needed to say for certain, detectors that wouldn't exist for another decade or more. By 2024, the VASCO project had become one of the most closely watched initiatives in astronomy. Its database regularly updated with new findings, its papers widely cited. Universities began offering courses on vanishing astronomical phenomena, bringing together astrophysicists, theorists, and even philosophers to grapple with the implications. If the vanishings were natural, they represented a gap in our understanding of stellar physics that needed to be filled urgently. If they were artificial, they meant we were living in a galaxy far stranger and more populated than we had imagined, where cosmic engineering occurred on scales that dwarfed anything in human experience. Either way, the universe was not what we had thought it was. The calm, predictable cosmos described in textbooks, where stars lived and died according to well-understood rules, had given way to something far more mysterious. A universe where the impossible happened regularly, and the laws we thought were fundamental might be incomplete or even wrong. The true climax of the mystery came in late 2024, when the James Webb Space Telescope, the most powerful observatory ever built, was directed to observe one of the reappearance cases in unprecedented detail. The star in question had vanished from its original position in 1963 and reappeared 4 arcseconds away in 2018. 55 years of absence, then a return displaced by a tiny but impossible distance. Webb's infrared instruments, capable of seeing through dust and detecting the faintest heat signatures, were focused on both the original position and the new one. What they found defied every expectation. At the original position, there was something there after all. Not a star, but a faint, perfectly circular disk of infrared emission, about the angular size of a large planet's orbit around a star. The disk glowed softly in thermal radiation, suggesting it was being heated by something inside, something Webb's instruments couldn't directly see. At the new position, the star itself burned normally, showing no unusual characteristics, just an ordinary red giant going about its slow stellar death. But here was the impossible part. Spectroscopic analysis showed that the star at the new position was identical to the star that had been at the old position. Same chemical composition, same mass, same age. The probability of two stars being that perfectly identical by chance was effectively zero. Somehow, the star had moved, or something resembling the star had been created in a new location, while the original was hidden behind the infrared disk. Neither explanation made sense within conventional physics. The data from Webb was analyzed and reanalyzed, checked for instrumental errors, reviewed by independent teams. Everyone reached the same conclusion. The observation was real. Whatever was happening to these stars, it was physical, detectable, and completely outside our understanding of how the universe worked. The night the findings were published, astronomers around the world stayed up late, reading the paper over and over, trying to find some conventional explanation they had missed. None existed. One researcher, a veteran of 50 years of stellar observation, was quoted saying he felt like Galileo must have felt when he first turned a telescope to the heavens and saw moons orbiting Jupiter. Proof that not everything in the cosmos orbited the Earth. We were witnessing something that forced us to reconsider fundamental assumptions, to accept that we had been wrong about how reality worked at scales we thought we understood. The implications rippled outward through every field of science. If stars could vanish and reappear, what else might be possible? Could the same phenomenon affect planets? Could entire solar systems disappear behind causality shields, or through wormholes, or via mechanisms we hadn't yet conceived? The question of where these vanishing stars went, if they truly went anywhere, became one of the most important unsolved problems in physics. Funding poured into the Vasco project and related research. New surveys were launched, designed specifically to catch stars in the act of vanishing, to observe the process in real time rather than discovering it decades after the fact through archival comparisons. Telescopes around the world were networked together, creating a global monitoring system that watched thousands of suspect stars simultaneously, waiting for one to dim or disappear so that its death or transformation could be studied in detail. The philosophical implications were equally profound. Humans had always looked up at the stars and seen permanence, changelessness, a celestial sphere that turned eternally above our transient lives. The stars were navigational aids, timekeepers, sources of myth and meaning. To learn that they could vanish, that the sky itself was mutable and unpredictable, struck at something deep in our collective psyche. If the stars weren't permanent, what was? The discovery forced a confrontation with cosmic impermanence, with the reality that even on astronomical scales, nothing lasts forever. And some things might not even last as long as we'd assumed. And if the vanishings were artificial, intelligence was at work on these scales, then humanity's place in the cosmos was far smaller than even our most humble estimates had suggested. We were not observers of an empty universe, slowly filling it with meaning through our exploration and understanding. We were late arrivals to a crowded galaxy, noticing for the first time the structures and modifications built by civilizations so far beyond us that we could barely detect their existence. As 2025 began, the mystery remained unsolved, but no longer ignored. The Vasco project continued its work, the catalog of vanishing and appearing stars growing monthly. New theoretical papers appeared weekly, proposing mechanisms both natural and artificial, each trying to account for the impossible observations. Some researchers focused on exotic stellar physics, on ways that quantum effects might scale up to stellar masses under rare conditions, causing stars to tunnel through space-time or phase shift into states we couldn't detect. Others explored the implications of extra dimensions, suggesting that stars might be falling out of our three-dimensional space into higher dimensional realms that we couldn't access or observe. And still others, the ones willing to embrace the most speculative possibilities, worked on the implications of galactic-scale engineering, trying to understand what kind of civilization would build Dyson spheres, or causality shields, or stellar engines, and what we might learn from detecting their presence. The search intensified for stars that were currently dimming, candidates that might vanish in the near future. If astronomers could catch one in real time, observing it continuously as it faded away, they might finally understand the mechanism. Dozens of stars were identified as potential candidates based on unusual brightness variations or spectral anomalies. Telescope time was allocated, instruments were prepared, and the astronomical community waited with a mixture of excitement and trepidation. What would it mean to watch a star die in a way that shouldn't be possible? What would the light curves look like as it happened? Would there be any warning? Any signature that could be detected and used to predict future events? The questions multiplied faster than the answers, each observation raising new puzzles, each theoretical paper opening new possibilities. In the depths of the cosmos, far beyond human eyes and instruments, the process that had claimed hundreds of stars continued its work. Whatever it was, stars that had burned for millions of years winked out of existence, leaving only darkness and questions behind. Others appeared where nothing had been before. Impossible births or impossible returns, defying the orderly progression of stellar evolution we thought we understood. And the night sky, seemingly eternal and unchanging, revealed itself to be neither. Just a snapshot of a dynamic and deeply strange universe where the rules were still being written and nothing could be taken for granted. The documentary ends not with answers, but with wonder, with the recognition that we live in a cosmos far more mysterious than our ancestors could have imagined. The vanishing stars are out there still, some already gone, others perhaps in the process of fading, even as you look up tonight. Each point of light in the darkness carries with it the question, will it still be there tomorrow, or next year, or next century? And if it vanishes, will it leave any trace of its existence? Or will it simply cease to be, as if it had never burned at all? We stand at the beginning of a new era of astronomical discovery, one where the heavens themselves are less certain than we believed, where stars can disappear and reappear, and where intelligence might already have reshaped the galaxy in ways we're only just learning to detect. The universe has revealed a secret, whispered across decades of photographic plates and digital sensors, spoken in the language of absent light and displaced stars. What else is it trying to tell us? What other impossibilities await discovery, hidden in plain sight among the countless points of light scattered across the night? The stars are not what we thought they were. The question now is what they actually are, and what their vanishing might mean for us, tiny observers on a small planet, looking up at a sky that grows stranger with each passing year, each new observation, each impossible discovery that forces us to admit we understand far less than we imagined about the cosmos we call home.